Hello dear students, I am Ronak Kumar, your physics faculty at Aakash, and a very warm welcome into this session in which we are going to deal with the problems of AIATS plus phase 2, and it was mock test 1 that was conducted on 19th of January 2025. And I will be taking the problems based on the chapter of current, electricity, motion in straight line, kinetic theory, thermodynamics, right, and EM waves. Now, based upon the inputs that we got from the AIATS plus phase 1, we came to know that it was very fruitful for all of the students who are preparing for the NEET examinations. So here we are back with the phase 2 program. Till now you must have gone through the discussions of botany, zoology and chemistry, and you enjoyed that discussion thoroughly. Now this day is dedicated for the physics part of this paper, and I'll be taking the problems of the problems of the chapter that I just mentioned, right? Now let me go through the first problem of this paper, and it is a problem based on the chapter of alternating currents, right? Alternating current, a very important chapter from the point of view of NEET examinations. And the problem says that a transformer, it has 200 primary turns and 10 secondary turns. If Vp, what is Vp? Vp is the primary voltage. If Vp is 220 volt, then you need to calculate Vs. Now, what is Vs? It is the secondary voltage, right? Now, let me solve this for you. Before solving, you must note that, okay. Before solving, you must be thorough with the concepts of the problem. See, I'll write it for you. Vs, let us first understand the terminology. Vs, it represents the voltage across the secondary, and upon Vp, it represents the voltage across the primary, right? And it will be equal to Ns by Np. And what is Ns and what is Np? Ns, it is the number of turns in the secondary, and what is Np? Similarly, Np represents the number of turns in the primary. So Vs by Vp, it is equal to Ns by Np. One more thing, I will write it over here. It is equal to Ip over Is. There you go. This relation is sufficient to solve any such kind of problems which may be asked in the upcoming NEET examinations, right? You must be clear, thorough with this ratio that I am just showing you on the board, right? So this is the max concept that this problem involves, and if you are thorough with this, you can get your answer. Now let me solve this for you. According to the problem, you see that it has 200 primary turns and 10 secondary turns. So the value of Ns, it is given to me as 10, and the value of Np, it is given to me as 200. What else is given to me in the problem? I have been given Vp. The value of primary voltage is given to me as 220 volt. Okay, 220 volt. Now I need to calculate Vs. So I'll use the relation Vs by Vp, it is equal to Ns by Np, right? And okay, and in place of Vs, I'll write Vs. In place of Vp, I'll write Vp as 220. And in place of Ns, you see Ns is 10. So in place of Ns, I'll write 10, and in place of Np, I'll write 200. So there you go. Now the problem is a simple problem. You just need to do the calculation part. So Vs is coming out to be equal to, from here if I solve, Vs is coming out to be equal to 22 by 2, that is equal to 11 volt. See, Vs is coming out to be equal to 11 volt. And let us go through the options to understand which should be the correct answer. The first option is 4400 volt. It cannot be the right answer. The second option is 11 volt, and that is what we got. So this can be the correct answer. Obviously, this is the correct answer. 220 volt, obviously it is wrong. 10 volt, obviously this is also wrong. Okay, see, I can see a lot of comments. Good morning, very good morning to all of you. I hope the day is going well for you. So yes, we got our answer. Answer is 2, right? That is 11 volt. Now let us understand what else can be asked in such problem. See, right now the VP that was given to me was as 220 volt, and Vs I just calculated, it was coming out to be equal to 11 volt. Now you can very well see that in this case Vs is less than Vp, and there is a specific name for such kind of transformers. We call them as step down. We call them as step down transformers, right? What do we call them? We call them as step down transformer. If Vs is greater than Vp, the name will be step up. So you must be thorough with the name also. What is the meaning of step down? What is the meaning of step up, right? So Vs is greater than Vp, that means it is a step up, and Vs is less than Vp, that means it is step down, right? Now let me do this, that this problem was telling you that it has 200 primary turns and 10 secondary turns. Now for your further clarity, let me reverse this ratio. What I'm trying to tell you is that, let me reverse the ratio for you, and I'm taking the turns in secondary to be equal to, okay, I'm taking the turns in secondary to be equal to 200, and I'm taking the turns in the primary to be equal to 10. And can any of you tell me what should be the ratio of secondary to the primary voltage? Can any, okay, based upon this data, have a look at this data. If the number of turns in secondary is 200 and the number of turns in primary is 10, can any one of you tell me what should be the ratio of Vs by Vp? And if you are telling me the ratio, please do mention that whether it will be a step up or a step down transformer. Any one of you can comment the answer. Just put the answer in the comment box. I'll get the hint that you understood the problem. So Ns is 200, Np is 10. We need to calculate the ratio of Vs by Vp. Okay, still we have not got any answer. Let me solve this for you. So Vs by Vp, according to our concept that we just built, it is equal to Ns by Np. And Ns in this case is given to me as 200, Np is given to me as 10, so it is coming out to be equal to 20. So obviously Vs by Vp is greater, Vs is greater than Vp, Vs is greater than Vp, so this means that it is a step-up transformer. And if I had the value of any one of this, I would have calculated the either secondary or primary. So that's how you deal with such kind of problems. What else could be asked in this? What else could be asked in this? Okay. One more thing, output power. How do we write output power? Output power, it can be written as the product of secondary current and secondary voltage, right? What about the input power? Input power can be written as the product of primary current and primary voltage. Okay, these are two extra formulas that you need to remember while dealing with the problems of transformer. Okay, someone is giving me the answer. Yes, very well. Step up and 20. Yes, very well. Have a look at the power. So output power, that's how you write the output power. That's how you write the input power. How about the efficiency? Efficiency is the output power, how much output power is given to you, and for that output power, how much input is consumed. So it will be P out by P in. So P out, it should be equal to ISVS, and P in, it should be equal to IPVP. That's how you define the efficiency of a transformer. If the transformer is 100% efficient, in that case, the secondary P out will be equal to P in. So these are the concepts that you need to deal while dealing with the problems of transformer. A very simple concept, just be thorough with the ratios. Students tend to get confused among this ratio, so you must be very, very clear. Please note it down, very, very clear with this ratio, because it will help you to fetch the marks, right? I hope this problem is clear to you. The correct answer becomes the option 2, right? Now, let's move forward to next problem. and it is right in front of you. The problem 19 of the original paper, it says that which of the following is not the Maxwell's equation of electromagnetism? Have a look at the options. Have a look at the options. So you need to pick, okay, the keyword over here is which of the following is not, okay, which of the following is not. So the keyword over here is not. Not is the keyword over here. You need to be very, very careful while dealing with the problems, right? And these are the four options. E dot ds is equal to q by epsilon naught, b dot ds mu naught into m, e dot dl minus d phi by dt, and integral of b dot dl. Now, symbols, they carry the same meaning as you must have read, right? So you need to pick the incorrect equation according to the Maxwell's equation of electromagnetism. A little bit, I'll put this in a little bit tougher problem, because students, they tend to get confused among all these equations. So let me solve this for you. The first equation is E dot ds. It is a E dot ds. What is E dot ds? It is electric flux. E dot ds is electric flux, and net electric flux through a closed surface, closed curve, it is equal to q by epsilon naught. What is this? This is Gauss law. Gauss's law. I hope you know E dot ds equal to q by epsilon naught. You have done a lot of problems on this, that net electric flux, it is equal to net charge enclosed by the surface divided by the epsilon naught. So Gauss's law for electrostatic, E dot ds equal to q by epsilon naught. This is a perfectly correct one. This is a perfectly correct equation according to the Maxwell's equation of electromagnetism. So this one is perfectly correct. It cannot be our answer. Let's come to the second. Closed integral b dot ds. What is b dot ds? B dot ds is the magnetic flux. This term b dot ds, it represents the magnetic flux, and it is telling you that b dot ds, it is equal to mu naught times m. M you can represent as magnetic monopole. So b dot ds, it is equal to mu naught m. Based on my experience and knowledge, this should be a wrong answer, because magnetic monopoles don't exist. If you take a closed curve and you try to calculate the magnetic flux, since the magnetic monopoles don't exist, both the poles will exist, the south pole as well as the north pole. So the cumulative effect will be such that the net magnetic flux through that closed surface will be 0, right? So b dot ds equal to mu naught m, it is a perfectly wrong statement, because magnetic monopoles don't exist. Or you can understand it as that the number of field lines entering must be equal to the field lines leaving, because magnetic field forms continuous closed curve. So this one is wrong. B dot ds should be equal to 0. Had it been equal to 0, this equation would have been correct, but in this case mu naught m, it is a perfectly wrong, and it should be the correct answer. Let us go through the other options. Third one says that E dot dl. What is E dot dl? It is a E dot dl. Okay, this is a line integral, and it is equal to minus d phi by dt. Okay, this is the Faraday's law. It tells you that the rate of change of magnetic flux with respect to time, it gives rise, the change of magnetic flux with respect to time, it gives rise to the induced electric field. So you must have done a lot of numericals on the induced electric field, and this equation is perfectly correct. It represents the Faraday's law, right? So this one is also correct. Let's talk about the fourth one. B dot dl. Again, line integral of magnetic field, it is equal to mu naught times I. What is I? It is modified form of Ampere-Surguttel law. What is I? I is your conduction current. Epsilon naught d phi e by dt. What is this term? This term is a displacement current, right? If I want to write it, I will write it like this. B dot dl, line integral of B dot dl, it is equal to mu naught times of IC plus ID. Okay. Let me make it again. IC plus ID. So this one is the conduction current, and this one is the displacement current. It is written, it can also be written as B dot dl, it is equal to mu naught times IC plus epsilon naught d phi e by dt. That's how you can also write it. So modified Ampere-Surguttel law is what I have written on the board. So this one also seems to be correct. So this one also seems to be correct. So this cannot be our correct answer. So the correct answer to this problem should be option 2, because we need to pick which is not the equation, right? Dipoles existing, dipoles. Okay. So according to our analysis, the correct answer to this problem should be option 2, and I hope this problem is clear to you, right? Just be thorough with the concepts. Don't try to remember the form equation. Just be thorough with the concepts, and you are good to go with such kind of problems, right? Now let's move forward to next. Okay, this was the problem 27 in the original paper, and this problem is based on the concept of most probable speed. Most probable speed, or you can, this problem is from the chapter of kinetic theory of gases, right? And it says that which of the following possess maximum most probable speed? VMP, most probable speed is VMP. So to solve this problem, you must be thorough with the three velocities: the most probable, the average, and the RMS. I'll write down the expression for all the three velocities right in front of you, right? So, okay, I'll write it over here only. V most probable, it is equal to root 2 RT by M. This is the expression for the most probable. V average, it is equal to under the root of 8 RT by pi M. And your favorite, that you must remember, VRMS, it is equal to under the root of 3 RT by M. So these are the three formulas that you need to remember to solve such kind of problems. Any of these can be asked from you, either the most probable, either the average, either the RMS, right? So we need to calculate the which of the following possess maximum most probable speed. So most probable speed, you can see that this R is universal gas constant, and it is common in all these threes. So this is not going to impact. This is your molar mass, and this is your temperature. Now, the very important point that you must keep in mind is that this temperature T, it should be in Kelvin. This temperature T, it should be in Kelvin. Don't try to put a temperature in degrees Celsius. It will be disastrous and you will get the wrong answer. So temperature should be in Kelvin. This is the key point, and you must remember all the formulas to solve such kind of problems. Now let us try to solve the problem. So we need to calculate the maximum one. So all of them are at the same temperature. Since all of them are at the same temperature, so this T, V most probable, as you can see that it is equal to root 2 RT by M. All of them are at the same temperature, so V most probable will be inversely proportional to the molar mass. This is the concept that I am going to utilize to solve problem. V most probable, it is inversely proportional to the molar mass. So that's how you can calculate which of them will have the most possess maximum most probable speed. Now oxygen, hydrogen, carbon dioxide, and helium. Okay, someone tell me what should be the molar mass of oxygen? What should be the molar mass of hydrogen? What should be the molar mass of CO2? And what should be the molar mass of helium? Come on, you just went through the chemistry classes. I hope you are clear till now. Okay, someone is commenting me the answer. Shashwat Tiwari, very well. Let me solve this for you. Can someone tell me what should be the molar mass of the oxygen? Okay, I'll write it for you. It will be 32. What about hydrogen? Okay, someone is commenting. Okay, it should be 2. What about CO2? Anyone? CO2? I'll write it for you. It should be 44. And what about helium? It should be 4. So since most probable speed is inversely proportional to the molar mass, so less will be the molar mass, more will be the most probable speed. Or I can say that jitna, okay, someone is commenting, yes, जितना ज़्यादा आपकी मोलर मास होगा, जितना ज़्यादा आपका मोलर मास होगा, उतना कम आपकी मोस्ट प्रोबेबल स्पीड होगी. ओके, राइट. So among all these four, the least molar mass is for hydrogen. So according to our analysis, the maximum most probable speed, it should be for the hydrogen. So the correct answer should be option 2. Have a look at the option. The correct answer should be option 2. That is, it cannot be oxygen, it should be hydrogen, it cannot be carbon dioxide, and it cannot be helium as well, right? So it should be hydrogen. Now what else can be asked? Okay, someone is 444, very well. Now what else can be asked in such kind of problem? They can make you compare. Suppose that I have hydrogen, right? And I need to calculate the ratio of RMS velocity, RMS at two different temperatures. One is 27 degrees Celsius and one is 127 degrees Celsius, right? So one is 27 degrees Celsius, one is 127 degrees Celsius. The gas is hydrogen. Tell me the ratio of RMS velocity at two different temperatures. One is 27 degrees Celsius and one is 127 degrees Celsius. If the answer is coming in root, just let it be in the root. Comment the answer in the comment box. What should be the ratio for the RMS velocity till up till then? I'll write the expression. It is equal to under the root of 3 RT by m. Okay, can someone comment me the answer? I'll use my tip that temperature must be in Kelvin. So 27 degrees Celsius in Kelvin, it should be equal to 300 Kelvin. And 127 degrees Celsius in Kelvin, it should be equal to 400 Kelvin. Right? Temperatures need to be in Kelvin. Okay, someone is commenting the answer. Let me solve this for you. V at 27 upon V at 127, it should be equal to, now the gas is same, R will be same, M will be same. The only factor that will decide the answer over here will be temperature, right? So directly proportional to temperature, I'll write it over here, 300 by 400. Let me cancel the two zeros. So it will be equal to root 3 by 4 or root 3 by 2. It will be equal to root 3 by 2. Very well, okay, very well. If you understood this concept, you are good to go with such kind of problems in the NEET examinations. And what else can you conclude? The comparison ratio among all these three velocities are also asked from you. So from here I can write that. Have a look at this ratio, V most probable, V average, and V RMS. You can also keep this in mind for solving. Maybe they could ask you, they could make you the comparison of most probable, average, and RMS for the same gas, right? So this concept, all these three formulas are the things that you need to keep in mind. If you want to take the screenshot, you can have the screenshot, right? And with this, I end this question and I'll move to the next problem. And the next problem is right in front of you. Problem 28 of the original paper, and it says that temperature of 1 mole of an ideal gas is raised by 2 degrees Celsius by a process. Okay, temperature of 1 mole of an ideal gas is raised by 2 degrees Celsius by a process. The internal energy would be maximum if the process is. So we need to tell that internal energy would be maximum for which process, and the process is isochoric, adiabatic, isobaric, and equal for all the processes. Okay, fourth one is a very interesting option, equal for all the processes. Okay, RAMS, RAMS. Someone is writing RAMS. Okay. So we need to calculate the internal energy change. Now, this problem is based on the chapter of thermodynamics, right? And I know that delta U, let me represent the change in internal energy by delta U. So delta U, it is a very basic concept that delta U is a state function. I'll write it as point function. What is the meaning of this? Delta U is point. Okay, someone is commenting answer isobaric. Okay. Okay, someone is commenting a trick, RAM. Very well, RAM. They are commenting the trick for the previous problem, RAM. Okay. Okay, delta U is a point function. And what is the meaning of point function? Suppose that I have a state A and I have a state B. And my gas is taken from state A to state B via three different processes. I am representing the process. This is one process, this is another process, and this one is another process. My gas is taken from state A to state B via three different processes. Let me take one as isobaric, let me take two as adiabatic, and let me take three as isochoric. Okay, so my gas is taken from A to B via three different processes, 1, 2, and 3, and I need to calculate which process among all these three should be there in which the internal energy change is maximum. Now, dear students, delta U is a point function. What is the meaning of point function? It only depends upon the initial and the final state. Since the initial and the final state in all these three processes is same, the change in internal energy will be same in all these three processes. That is the concept that you need to understand. Since delta U is a point function, the change in internal energy will be same in all these three processes. It means that the correct answer for this will be equal to option 4, that is equal for all the processes, right? Delta U, the expression for delta U is NCV delta T, and you can use this expression delta U, it is equal to NCV delta T. You can use this expression irrespective of the process. Any process, if the delta T remains same, if the delta T remains same for all the processes, you can use this expression because delta U is a point function, right? So for isobaric, if I try to write for the isobaric process, delta U will be equal to NCV delta T. And what should be delta Q? Anyone, what should be delta Q? Delta W max for isobaric. My bad. Okay. No problem. Nothing to feel sorry. Delta Q for the isobaric process, it will be equal to NCP delta T. Right. Let's talk about isochoric. For isochoric delta U, it should be equal to NCV delta T. What should be delta Q? Isochoric. Anyone? What should be delta Q for the isochoric process? Delta W max for isobaric, my bad. Okay, same option. Delta Q should be equal to delta U and it should be equal to NCV delta T, right? Because delta W is 0 for the isobaric process. And what about adiabatic? What about adiabatic process? See, adiabatic is simple. Adiabatic, no heat interaction. Delta Q will be equal to 0 and delta W should be equal to NCV delta T. So if the change in state is same, delta U is going to remain same because it is a point function. Correct answer is option 4, that is equal for all the processes, right? And you can have a look at this, that how do we write a delta Q and delta U for isobaric process, right? How to write delta U and delta Q for isochoric process, and how to write delta Q and delta U for adiabatic process. Simple. That is what you need to remember to solve this problem, right? Now, let's move forward to the problem 42. It was problem 42 in the original paper and it is based upon the current electricity. As I can see, it says that in the network shown in figure, the current in R5 is, so you need to calculate the current in R5. Okay. By looking at the problem, I can say that this problem is based on the concept of conservation of charge, or I can write that this problem is based on the concept that incoming current should be equal to outgoing current at a junction, obviously. incoming current should be equal to the outgoing current, and this is based upon the conservation of charge, right? So you can see that I1 is entering over here, I1 is entering over here, and this I1, it is being distributed into I2, and it is being distributed into I3 at this junction, right? This is my junction. So I1 is the incoming current, and it got distributed into I2 and I3, right? So from here I can write that I1, it should be equal to I2 plus I3, right? I1 should be equal to I2 plus I3. Now we need to calculate the current through R5. Here is your R5. I'll take this junction. Let us apply the concept at this junction. So here the incoming current is I3 from this side, and I2 is coming from here. So I2 is also the incoming current at this junction. So for this junction I can write that incoming current. What is the incoming current? It is equal to I3 plus I2. This is the incoming current, and it should be equal to the, when to use formula, NCP delta T, sir. NCP delta T. NCP delta T is the heat interaction delta Q for the isobaric process. I just told you in the last problem that we just discussed. Have a look at this problem. So for this junction, the incoming current will be I3 plus I2. Let me take the current through R5 as capital I. So I3 plus I2 should be equal to capital I. Net incoming current, it should be equal to net outgoing current. So the current through R5, it should be equal to I3 plus I2, right? I3 plus I2, I3 plus I2, okay. Have a look at the options. None of the options says that I3 plus I2. So what do we do now? Have a look at this equation. From this equation, I can write that this I, that is equal to I3 plus I2, it is equal to I1. What I'm trying to say is I1 is equal to I2 plus I3, and I2 plus I3 is equal to capital I, that is the current through R5. So I will be equal to I1. I should be equal to I1, and I should be equal to I1. It means that the correct answer should be option 1. Someone commented the answer, yes, Kirchhoff's current law. So this one is wrong, this one is also wrong, and this one is also wrong. A fairly simple problem, I'll say it is a fairly simple problem. It is based on the conservation of charge. At the junction, you just need to balance the incoming and the outgoing current, and you are good to go with such kind of problems, right? I hope this problem is clear to you. I1, I1. Okay, someone is commenting the answer I1. Good. Let's move forward to next problem. Okay. It is problem 43 in the original paper. Can someone tell me the answer? What should be the answer to this problem? Okay, can someone tell me the answer? What should be the answer to this problem? This problem is based on the chapter of motion in straight line, right? And let me go through the problem. It says that a car travels first 10 seconds with uniform acceleration. So the car is traveling for the first 10 seconds with uniform acceleration of 2 meter per second square. Okay, so the car is traveling with a uniform acceleration of 2 meter per second square from rest. Keywords, it is starting from rest and it is moving with a uniform acceleration, right? On straight road, and then travels with zero acceleration for next 10 seconds, the average speed of entire journey. You need to calculate. Okay, someone is giving me the answer 20. Option 1, someone is telling me the answer as option 1. I don't think this should be the correct answer. Let me solve this for you. What is the formula for average speed? V average. How do we calculate the average speed? It's a simple problem. V average. Okay, someone is commenting the answer 15 meter per second. Okay, let me solve this for you. V average is total displacement, total distance upon the time taken, to cover this distance, right? So total distance upon time taken. Now the time taken to cover the distance is 10 second plus 10 second, that is 20 seconds. So this is equal to 20 second. Okay, now the problem reduces to the fact that I just need to calculate what is the total distance covered. because time taken is 20 seconds. That I have figured out with the help of problem only. How to calculate total distance? Now for the first 10 seconds, so from t equal to 0 to t equal to 10 seconds, let me analyze the motion for you from t equal to 0 to t equal to 10 seconds. In this motion, the particle starts from rest. Particle starts from rest, so u is equal to 0, and it is moving with a constant acceleration of 2 meter per second square. 2 meter per second square. So I need to calculate the distance covered by the body at the end of 10 seconds, right? So I can use this equation S to be equal to ut plus half AT square, right? I'll put u as 0 because initially the body is starting from rest. So S, it reduces to half AT square. Half AT square. Now you just need to put the value half. The uniform acceleration is 2 and time taken is 10 seconds. So 10 into 10. Let me cancel this for you. So S is coming out to be equal to 100 meters. S is coming to you as 100 meters. Now, for the next 10 second, from t equal to 10 second to t equal to 20 second. In this time interval, the acceleration of the body is 0. So whatever is the velocity of the body at t equal to 10 second, the body will continue moving with that velocity only. So the problem reduces to the fact that what should the velocity at t equal to 10 second. For this, let's go back to this motion. So at the end of 10 second, what should be the velocity of the body if the body is starting from rest and moving with a uniform acceleration of 2 meter per second square? Use this equation okay, I'll write it over here. I'll use the equation v is equal to u plus at, right? Now body is starting from rest, I'll put u as 0. So this equation reduces to v is equal to a into t. V is equal to a into t. Now velocity is what I need to calculate. Acceleration, it was 2 and time was 10. So it is coming out to be equal to 20 meter per second. Okay, this is the velocity at the end of 10 seconds that we just calculated with this information. Now I need to calculate the distance traveled in next 10 seconds. So S will be equal to V into T. So it will be equal to 20 into 10, that is 200. Right? Now let's get back to the original problem. So V average, it is defined as the total distance. Total distance was 100 from t equal to 0 to t equal to 10 plus 200 from t equal to 10 to t equal to 20. Total time taken is 20. So 200 plus 100 is 300 divided by 20. I guess it is coming out to be equal to 15 meter per second. Okay. There you go, you have your answer right in front of you, 15 meter per second, which is given to me in option 2. Yes, Shashwat Tiwari commented the right answer, it should be equal to 15 meter per second only. Yes, very well. Okay, what else? You can be asked the average velocity in this in such kind of problems also. So let's not go to that. You can be asked the velocity time graph or the speed time graph for this. So that's how you approach such kind of problems, right? I hope this problem was clear to you. Let's move forward to the next problem. It says that, okay. Now this problem is based on the chapter current electricity. If the key joining C and D is closed, then we need to figure out if the key K joining C and D is closed. If this key is closed, then the direction of flow of current is what we need to determine. Whether it will be from C to D, whether it will be from D to C, or no current flows between C and D, or value of V is required to predict direction of current. Okay. So dear students, this is a difficult problem as per my suggestion. This is a difficult problem, right? Let us try to solve this problem. So let me draw the figure for you. No, let's work on this figure only. So this resistance is 10 ohm, this resistance is 30 ohm, this one is 20 ohm, and this one is 40 ohm. My first guess is that it is not a balanced Wheatstone bridge. This is not a balanced Wheatstone bridge. Had it been a balanced Wheatstone bridge, okay, it is not a balanced Wheatstone bridge. Had it been a balanced Wheatstone bridge, no current will flow from C to D. So correct answer should be option 3 only, right? अगर ये balanced Wheatstone bridge होता तो इसका correct answer बनता option 3, that is no current flows between C and D. But obviously this is not a balanced Wheatstone bridge. How do we check the condition for the balanced Wheatstone bridge? Anyone? Give me the ratio. Give me the ratio for the balanced Wheatstone bridge. Let me take this as R1 and let me take this as R2. Let me take this as R3 and let me take this as R4. So if R1 by R2 it is equal to R3 by R4, in that case the bridge will be balanced, but obviously you can see that R1 by R2 is 1 over 3 and R3 by R4 is 1 over 2. So this, okay, yes, R1 by R2 equal to R3 by R4, very well. So 1 by 3, 1 by 2. This is not a balanced Wheatstone bridge. We need to do some more analysis to figure out what should be the direction of current. Okay. So the circuit is something like this. I have one resistor like this, and I have one resistor like this, right? I have one resistor like this, and I have one resistor like this, and a battery is connected like this, right? And this is your point C, this is your point D, here is your key, right? Let me take the resistors 10, 30, 20, 40. So this one is 10 ohm, this one is 30 ohm, and this one is 20 ohm, and this one is 40 ohm. Please ignore the drawing. That is the best I could manage. Now, if this part is broken, then I can say that, I can say that the effective resistance across this branch, it is equal to 10 plus 20, and it is equal to 30 ohms, right? And effective resistance across this branch, it will be equal to 30 plus 40. 30 plus 40, it is equal to 70 ohm. And you can see that this 30 ohm, multiply the corner resistance, it should be same, okay? Multiply the corner, it should be same, okay? We'll multiply. So this 30 ohm and this 70 ohm, this 30 ohm and 70 ohm, they are in parallel combination. So if I assume that the current through this is I1 and the current through this is I2. So same current I1 will flow through this also, and same current I2 will flow through this also, right? So this 30 and 70, they are in parallel combination. So I can write that. 30 into I1, it should be equal to 70 into I2. Because the potential drop will remain same, let me take this to be equal to K. So I1 from here, it becomes equal to K by 30. And I2 from here, it becomes equal to K by 70. I1 is K by 30, I2 is K by 70. Now, let me take the potential at this point as V, and let me take this as Vc, and let me take this as Vd. So if a current I1 flows through this, I can write that V minus Vc, current always flow in the direction of decreasing potential. So V minus Vc, it will be equal to 10 into I1. What is the value of I1? It is K by 30. K by 30, if I'm not wrong, yes. So it is equal to K by 3, right? Similarly, if I try to write, I'll write here only, V minus Vd, I'll write in a different page, V minus Vd, it will be equal to, the resistance over here is 30, so 30 into I2. What is the value of I2? We just calculated. I2 is K by 70. So let me write it over here, K by 70. So it is 3K by 7. So V minus Vd is equal to 3K by 7. So V minus 3K by 7 is VD, and V minus K by 3. V minus K by 3 is equal to VC. Now, use this equation. From this equation, I can clearly conclude that VC should be greater than VD. Okay, any doubt in conclusion of this statement? VC is greater than VD from these two equations? Okay, the comment box is dry. So VC is greater than VD. VC is greater than VD is the conclusion that we are getting. That means that in the original circuit, this VC, it is at higher potential, and this VD, it is at lower potential. And the direction of current is from higher to lower potential. The direction of current is from higher to lower potential. That means that the current will flow from point C to point D. That means that the correct answer to this problem should be current flows from C to D. Current flows from C to D, and current flows from D to C is wrong. No current, obviously this is wrong. Value of V is required to predict direction of current. This one is also wrong. We can predict the value of V if we don't know the value of current. So yes, the correct answer becomes current flows from C to D. I hope this problem was clear to you. No sir, no any doubt. Thank you. Option 1, yes. What else? Okay, I hope this part was clear to you. A little bit of, this problem was on a tougher side. We need some analysis to reach to the conclusion that VC is greater than VD. कोई direct numerical value आपको दी नहीं गई थी to conclude this, but you can keep the tricks in mind. You can go through the problems and just remember for the future reference how to calculate such kind of problem. Okay. Now, dear students, let me discuss some additional topics with you. And we'll be discussing the first law. We'll be discussing the heat engine. We will be discussing the heat engine. Okay. Okay, let me rub some slides. Just some technical glitch. Let me get back to you. Okay. So I'll discuss with you the topic for the discussion is heat engine. It is an additional topic that we are going to discuss with you. Okay. So I'll be discussing heat engine, right? A very important topic from the point of view of NEET examinations. One problem, you can expect one problem from such kind from this topic in the NEET examinations. What is a heat engine? So the basic construction of heat engine is something like this. You have a reservoir which is at a higher temperature. Let me take this temperature as TH. So you have a reservoir which has an infinite heat capacity. The temperature of this reservoir is TH. And you extract the heat from this reservoir, and this is your working cycle. So it extract heat Q1 from this reservoir TH, right? And since it is a heat engine, it gives us some work output WO. And while giving this work output, this heat engine rejects some heat to low temperature reservoir whose temperature is also TL, and the heat rejected is Q2. So this is the basic construction of a heat engine. You have two infinite heat capacity reservoir. One is at higher temperature and one is at lower temperature, TH and TL, right? Now, what is the purpose of keeping the saying that these two have infinite heat capacity? The purpose is that even if you extract heat or even if you reject heat, there is not going to be change in the temperature, right? So the temperature is going to remain constant for both of these. So TH and TL, right? This is the basic construction of the heat engine. What is the purpose of the heat engine? Purpose of the heat engine is to give us some work output, right? So if I apply the first law of thermodynamics in this cycle, I can write that Q1, it should be equal to W plus Q2. Q1 should be equal to W plus Q2, or I can write that W should be equal to Q1 minus Q2. W should be equal to Q1 minus Q2. Right? So according to the Carnot's, efficiency of a heat engine, okay, I am taking it, all the processes are reversible. If I am taking a reversible, so efficiency of heat engine is work output upon heat input. Work output upon heat input, that's how you define the efficiency of a heat engine. What is work output? Work output over here is W naught. And what is the heat input? Anyone, what should be the heat input? Can someone tell me what should be the heat input? I'll write it for you, W naught by Q1. It should be the heat input. And that's how you define the efficiency of a heat engine. And if it is a Carnot, if it is a Carnot heat engine, it should be equal to 1 minus T lower by T higher. Because if this is a Carnot heat engine, I can say that Q1, it should be proportional to TH, and Q2, that is heat rejected, it should be proportional to TL, right? So work output, it can be written as Q1 minus Q2 by Q1, right? And if I'm assuming this, okay, Q1, okay, and if I'm assuming that Q1 is proportional to TH, so I can modify the efficiency like this. In place of Q1, I will write KTH. I'm removing the proportionality. KTH minus KTL over Q1, that is KTH. So just remove K, 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 and K, so it becomes TH minus TL by TH, or it is equal to 1 minus T lower by T higher. Q1, yes, very well. So that's how you deal with the heat engine. Now, one of the confusion that students tend to confuse, that what is the difference between a heat engine and what is the difference between a refrigerator. I hope refrigerator is not in the syllabus, so let's avoid that part. So Q1 is the heat input. Let me write it for you also over here. Q1 is the heat input. Q2 is the heat output. Sorry, heat rejected. And W naught is your work output. Okay, any doubt in the heat engine? Any doubt in the heat engine? Any of you? I'm waiting for your doubts. Put your doubt in the comment box if you have any doubt in the heat engine or the problems we just discussed before this. Okay, comment section is dry. No reply. So dear students, this is how you deal with heat engine. That is the formula of efficiency that you need to keep in mind to deal with such problems, right? Right, and that's how you merge the Carnot efficiency with the general efficiency, right? Okay, comment section is completely dry. No comment. Afrin, all clear. Thank you very much. Any doubt? Can you please explain Carnot engine also? Yes, I can explain the Carnot engine also. We'll keep the explanation of Carnot engine in the next class. Till then, I'll take your leave. Very thank you to all of you for joining the class. I hope all your doubts are clear, and we'll meet in the next session, right? We'll be discussing the problems of other chapters in the next session. So please join the next